we are going to do some practice questions where 3 inputs are involved in the system. Here, we are going to follow the basic 4 questions. First of all, we are going to write the standard Boolean expression of the given output in the sum of products form, since we are using min terms. Then we are going to plot the K-map for the specific Boolean expression. Then we are going to simplify the expression. Finally, we are going to use only NAND gates. We are going to use only NAND gates to form the logic circuit design. First of all, we are going to find the min terms. Here we have M2, here we have M3, and here we have M5, and finally M7. This is the first step of the finding the Boolean expression part. So we can say if A, B, C, you can put A, B, C in the parenthesis, or you can just write F because they have given F here, but this just says there are 3 inputs, namely A, B, C. This is equals to M2. We know since this is min terms, only ones are considered present. So this will be A bar B C bar plus A bar B C plus we have A B bar C plus A B C. This is the first step. We are writing the Boolean expression. Now we are going to the second step. We are going to plot the K-map. And since this is 3 input system, we need 8 cells. It can be 2 by 4 or 4 by 8. We will use 2 by 4. This is the 2 by 4 K-map system that we are using. Let's name the directions. We normally name A, B here and then C here conventionally. You can change if you had used 4 by 2 K-map. Okay. I have taught you in the previous videos that we normally go with A bar, B bar, and then according to gray code, we will write the order A bar, B, and then it will be A, B, and then finally it will be A, B bar. You can do this, but in certain questions, they might not give the K-map like this. Sometimes they will give you ones and zeros. And these ones and zeros correspond directly to the inputs. They correspond directly to the inputs. What do I mean by this? Well, first of all, we wrote A bar, B bar, right? So they will say 0 and 0. Because A and B are not present. They are absent. And then we will have 0, 1. And then it will be 1, 1. Finally, it will be 1, 0. That's it. It's the same thing, but instead of the inputs, we use the values. Similarly, here also it will be 0 and 1. What it corresponds is, this is C bar, this is C, and this is A bar, B bar, and this is A bar, B, and then A, B, and finally A, B bar. These are small things. These are small things that you should keep in mind. Now, we will plot the graph. A bar, B, C bar. So, it will be now, let's plot the K-map. First one is A bar, B, C bar. So, we will put 1 here. Then we have A bar, B, C. So, A bar, B, C comes here. Then we have A, B bar, C. And it will come here. And then we have A, B, C, which will correspond to this specific cell. Now we have plotted the graph. Now we are going to the third step, where we will focus on the Boolean expression simplification by using K-map. So how can we do that? First of all, we have to group this. We can only have 2 groups simply because we should have minimum number of groups. And also largest groups possible. Since there is no way of getting 4 groups of 4, we are going to use groups of 2 to the power 1. And let's name this group. This is group 1. This is group 2. So the simplified expression will be equals to if A, B, C will be equal to. Here this is the column. This is in the column direction. So we will have A bar B. The C bar and C will cancel each other out. And then this is row wise. So we will have C. And B and B bar will cancel out. So we will have A bar B plus AC. This is the simplification. This is the utmost simplification that you can go into. Now, the final step, we are going to draw the logic circuit design using only NAND gates. We are going to use only NAND gates. Now, how can we do that? Well, let's consider if ABC is equals to A bar B plus AC. Now, if I apply the double complement, it will be if it's the same thing, right? It's the same thing, but it will have double complement over the given expression. So A bar B plus AC. Now I will break the lower bar. So it will give me A bar B whole thing bar into AC whole thing bar. That's it. Now I don't need to go deeper into this. I don't have to go deeper into this. I can use this. Since we have A bar and all, we might need more NAND gates. But this is the expression that can be used to form NAND gates on the logic gate circuit design. Okay, so how are we going to do this? Well, first of all, we'll write down A, B, and C. This is the fifth step. This is the next question. So I'll draw the diagram here itself. Okay, I'll draw the diagram here itself. The fifth step. So we will have A, we will have B, and we'll have C. This is the signal line, and we have C. We need A bar, so we will send A through a NAND gate twice. Then only we will get A bar. So here we will have A bar. This is A and this is A. How does this work? Well, I'll attach the link to the video. You can practice that also. Then we have A bar B whole thing bar. So we have to send A bar and B through a specific NAND gate. And we will do that here. Here. Now this is A bar B whole thing bar. Here we have A bar and here we have B. So this will be, let me put dots like this here so that you can see they are not actually overlapping, they are actually bending. So we will have A bar B whole thing bar, and then we also need AC whole thing bar. So it will go like this, and then C will go like this, and we can close this together. Here we have A, here we have C. So this will be AC whole thing bar. And finally, we will have to send them through another NAND gate. We'll have to send them through another NAND gate, and that will get us the final output. So this will be A bar B whole thing bar into AC whole thing bar. That's it. So for this specific truth table, we have to draw this specific logic gate. So we require 4 NAND gates. You can do this with NOR gates, but it will take you more than 4. So if you have to use the NOR gates, you have to use the max terms. That we will focus on the next video. For these same questions, I will explain using max terms. Now let's go to the second question. First of all, we will find the min terms. So it will be M1, M5, M6, M7. So the first step will be F is equals to A bar B bar C plus A B bar C plus ABC bar plus ABC. Now we have to plot the K-map. So let me draw the K-map. But this time I'm going to draw 4 by 2. Now I have named the directions A and BC. Here we will have A bar and then A. Then we will have B bar C bar. Then we will have B bar C. Finally, it will be BC bar BC and then B C bar. Now let's plot this. We have A bar B bar C. Next we have A B bar C. Next we have ABC bar and we have ABC. It's the same thing. Now we have to group them. If we group this, we will get two groups. And let's say this is the first group, and let's say this is the second group. And F will be equals to, we are simplifying now. So it will be B bar C, the first group. Then the second group will be A, AB. That's it. This is the furthest you can simplify. That's it. Looks easy, right? Now we can draw the NAND gates only logic gate circuit. So F will be equals to B bar C plus AB whole thing bar. Now that will be equals to B bar C whole thing bar into AB whole thing bar. Now if I draw the diagram, first of all we will draw the ABC circuit input lines. Then we can go to the next point. So that's it, A, B and C. Now we have B bar first, so let's send B through send B through a NAND gate twice, so that it will create B bar. So this is B, so the output will be B bar. And then we have to send this B bar through another NAND gate along with C. So it will be B bar C whole thing bar. B bar C whole thing bar, since this is C. Then we have to send A and B through another NAND gate. So let's do that too. A and B are sent through another NAND gate. And that will be A dot B whole thing bar. And finally, we have to send these two through another NAND gate. And the final output will be F, where F is equals to B bar C whole thing bar dot AB bar whole thing bar. And this is the second question done. The first question is done already. Just make sure to draw the dots, okay, so that you can clearly show they are not overlapping. They are connecting to each other lines, to other lines. That's it. Now we can go to the third and last question for this tutorial. So let's write down the min terms: M1, M4, M5, M6, finally M7. So this can be given as F is equals to A bar B bar C plus A B bar C bar plus A B bar C plus A B C bar plus ABC. Now we will do the K-map. I'll use 4 by 2 because conventionally it is used multiple times. Now let's name the directions A, B and then C. We'll use the numbers 0, 0, 0, 1, 1, 1, 1, 0, 0 and 1. We need A bar, B bar, C. So it will be here. A, B bar, C bar. So we have A here, B bar here, C bar here. A, B bar, C. So it will come here. And then we have A, B, C bar. So it will come here. And then finally we have A, B and C. So it will come here. Now what we have to do is we are going to group these things. Yes. So the third part is where we simplify this expression by grouping. So here I can group once, and then I can use the overlapping and wrapping around to create the second group. And this will be the first group, and this will be the second group. So F can be given as, if I consider here, A is present in both of them, A is present in both of them in the column wise and also in the row wise. What do I mean by this? Well, here this is AB and this is AB bar and this is C bar and C. So if you consider in the row column direction, AB will be present in both of them. AB and AB bar will be present. But the beauty is, if you think of it in the row direction, A only will be present, right? A C bar will be present, but since C is already cancelling out in the column direction, in the row direction, B and B bar will cancel each other out. So we will get A only. Only A is present and does not get cancelled out. A is only present and it is the only input that will not get cancelled out. Now let's go to the second one. Second, in the row direction, we have A B bar and A bar B bar. So B bar will be present and C will be present since this is in the row direction. And finally, we are going to draw the NAND gate solution. So F will be equals to A plus B bar C whole thing bar that is equals to A bar dot B bar C whole thing bar, which means we will need 1, 2, 3, 4 NAND gates. Here also we will need 4 NAND gates. So let's draw the ABC lines. First of all, we will need A bar. Then we will need B bar. And then we will need B bar C whole thing bar. And then we have to send all these through another NAND gate. That's it. So here we have A and A. So this will be A bar. This will be B and B. So this will be B bar. And this is C. So we will get B bar dot C whole thing bar. And the final output will be F equals to A bar dot B bar dot C whole thing bar. That's it. So this is how you have to practice these questions. And we will meet in the next video where we will be discussing about max terms for these specific questions. Thanks for watching the 30th video in our logic gate series. Now we have completed SOP 3 input questions. And if you found this guide to min terms helpful, don't forget to like, share and subscribe for more lessons. I'll see you in the next video. Until then, keep learning and stay curious.